Hello. So today I'm going to be conducting a simple ideal gas law PV equals nRT experiment. The tools I have with me today is a cooking thermometer which reads out to 1 decimal point, and I'm going to be keeping it in Celsius for today's experiment. I have my bicycle pump with a pressure gauge on it, and I have my basketball. And inside my basketball is the needle. And the reason I have my needle sitting into the basketball currently is so that it lets the air flow in between our surroundings and inside the basketball. So inside it should be at the exact same pressure as outside, so 1 atm about. Now I'm going to take this out of here, and I want to get the initial temperature reading for inside of our basketball. Hopefully it should be around the same that it is outside. Currently reading 26.0 degrees Celsius outside. And inside the basketball, this temperature, I let it stabilize a bit. It likes to start high and then go down low. But it's reading 28.5, so stop there. Now I'm going to increase the pressure. And with this increase in pressure, we should see an increase in temperature as they are on opposite sides of the ideal gas law. And the idea behind using this basketball is that our volume is staying constant. That's the reason I didn't press any air out of there or anything like that. And the basketball is pretty rigid for it being something that I can inflate. And so I'm just aiming for 1 bar here. I can only do 2 trials because I want to explode my basketball. But at 1 bar, we should read a higher temperature. And I'm going to have to give it some time to let it settle. But we're starting to stabilize, and we are looking at 29.0 degrees Celsius. Now I'm going to inflate it again to 1.5 bar. And I think that's kind of the max I can inflate this basketball without it exploding. But I'm going to do my best to adjust at that. Alright, on the dot, now we should see another increase in temperature due to the increase in pressure. .3, still going down. So it seems to have stabilized at 29.6 degrees Fahrenheit. So the initial goal of this experiment was for me to show the increase in temperature when you increase the pressure using the ideal gas law. However, as this experiment showed, obviously in a basketball, if you double the pressure, you're not going to have double the temperature. And I was trying to figure out why isn't this, and I realized I'm increasing the moles of gas. That's really what I'm doing to the basketball, is I'm putting more air in there with the pump. But the good news is I'm able to calculate the pressure, or I know the pressure, the temperature. Obviously you can find gas constant, and the volume is staying the same, and I know the volume of basketball. So what this experiment has switched to showing is that when you factor all those in, it's proving, the math here is proving that I am increasing the amount of moles into the basketball. So if you look here, we have our volume, which is constant. Here our temperature is converted to Kelvin. Here are our absolute pressures. And as you go through this, you can see that it's proving that we are increasing the amount of moles of gas in this basketball.